Have you ever just looked up at the night sky and wondered, how on earth did we figure all of this out? I mean, our picture of the universe has gone through some absolutely mind-bending changes. We went from thinking it was a flat plate on a turtle's back to, well, the Big Bang. So let's dive into that incredible journey.
You know, there's this great story about a scientist giving a lecture on astronomy. Afterwards, an old woman comes up and says, "That's all wrong. The world is really a flat plate supported on the back of a giant tortoise." The scientist, kind of smiling, asks her a very simple question.
And her reply? "Oh, it's legendary. You're very clever, young man, but it's turtles all the way down." Now, look, an infinite tower of tortoises probably sounds pretty ridiculous to us today, but it kind of begs the question, right? Why do we think we know any better?
That is exactly what we're going to explore. We're going to trace the key ideas, the big discoveries that took us from a cosmos full of myths to the expanding universe that we talk about today.
So, where does our modern picture of the universe actually begin? Well, not with turtles. It starts with the first great leap from myth to actual measurement, way back in ancient Greece. As far back as 340 BC, the philosopher Aristotle was using pure observation to prove the Earth was a sphere. He pointed out that, hey, look, the Earth's shadow on the moon during an eclipse, it's always round. That can only happen if the Earth is a sphere. He also noticed that the North Star gets lower in the sky the further south you go, which just wouldn't happen on a flat Earth. And of course, sailors knew this one for ages. You always see the sails of a ship peeking over the horizon long before you see its hull. These were just simple, elegant proofs based on what people could actually go out and see for themselves.
Now, Aristotle's idea of a stationary Earth smack in the center of everything was later built out by Ptolemy into this complete cosmological model. You had the Earth right at the center, surrounded by these nested crystal spheres that carried the sun, the moon, the planets, and all the stars. This whole picture, with plenty of room for heaven and hell just beyond that outermost sphere, it was comforting, it was compelling, and because of that, it was the accepted view for over 1,000 years.
But, Ptolemy's model had some serious problems. To predict where the planets would be, he had to make them move in these crazy circles within circles, and it got incredibly complicated. It even predicted the moon should sometimes look twice as big as other times, which obviously nobody had ever seen. Then, in 1514, this Polish priest named Copernicus comes along and proposes a radically simpler idea. What if the sun was at the center?
And that one simple idea? It kicked off a revolution in thought that would completely, and I mean completely, dismantle the old worldview.
And what followed was just this torrent of discovery. First, Copernicus offers his new model. Then Galileo, using the newly invented telescope, sees moons orbiting Jupiter, proving right there that not everything circles the Earth. In that same year, Kepler figures out that planets move in ellipses, not perfect circles. And then finally, Newton comes along and gives us the law that explains why it all works: gravity.
So here's the really crucial point in all this. The old, Earth-centered universe wasn't just disproven. The whole method of understanding it got replaced. These mystical ideas about perfect, heavenly circles just gave way to hard evidence from telescopes and the incredible predictive power of mathematics. Newton's work gave us our next great picture of the universe, and with it came a massive philosophical shift. The cosmos wasn't some divinely managed stage anymore. It was a vast, infinite clockwork machine, all governed by one single powerful law.
This was Newton's brilliant insight. He proposed that the exact same force that makes an apple fall to the ground is what keeps the moon in orbit around the Earth and the planets around the sun. It was a universal law, simple, powerful, and absolutely breathtaking. It suggested the whole universe was knowable and predictable.
But, and this is a huge but, this beautiful theory had a massive problem. Newton realized that if there were a finite number of stars, they'd all attract each other and eventually just collapse into one giant lump. He argued this wouldn't happen in an infinite universe, but we now know that even in an infinite universe, gravity would still cause it to collapse on itself.
So for centuries, this paradox just haunted physicists. The universe clearly was not collapsing, but according to the best theory they had, it should have been. It was this giant crack in the foundation of physics, a deep mystery that really suggested Newton's powerful theory of gravity was, well, incomplete.
And the answer came from, of all people, a clerk in the Swiss patent office, Albert Einstein, who didn't just tweak Newton's theory, he completely rewrote the rules of space, time, and gravity itself.
Okay, so Einstein's revolutionary idea was that gravity isn't a force that pulls things. No, instead, massive objects like the sun literally bend the fabric of space and time around them. Imagine a bowling ball on a trampoline. That's what the sun does to space-time. Planets aren't being pulled by the sun, they're just following the curves that its mass creates.
Now, to even get to this idea, Einstein had to completely demolish the notion of absolute time. His theory showed that time isn't universal. For example, if you put a clock on a super fast-moving spaceship, it would actually tick slower than a clock back here on Earth. Time itself is relative.
Einstein realized that space and time are basically two sides of the same coin, a four-dimensional fabric he called space-time. And this light cone you see here, that represents all of your possible futures. You can travel anywhere you want inside that cone, but you can never ever reach anything outside of it, because that would mean traveling faster than light. Your future is literally defined by the geometry of space-time.
So, Einstein's theory predicted a dynamic universe, one that couldn't possibly be static. And then in the 1920s, a monumental observation came along that proved he was right.
The key piece of evidence came from studying the light from distant galaxies. See, when a source of light is moving away from you, its light waves get stretched out. This shifts its color toward the red end of the spectrum, an effect we call redshift. It's basically the cosmic equivalent of a car's engine sounding lower-pitched as it drives away from you.
So in 1929, the astronomer Edwin Hubble makes a totally shocking discovery. He found that the light from nearly every single galaxy was redshifted. They were all moving away from us. But even more surprising, he found a clear pattern. The farther away a galaxy was, the faster it was flying away.
Hubble's discovery was the first real observational proof that the universe isn't static, it's expanding. The space between galaxies is actually stretching, carrying them farther and farther apart. And if we rewind the clock on that process, well, it means that everything in the universe must have been much, much closer together in the past.
And that logic leads to one single, unavoidable conclusion. If you go back far enough, about 13.8 billion years, all the matter and energy in the entire universe must have been concentrated at a single, infinitesimally small and infinitely dense point. For the first time ever, the question of the universe's beginning moved out of philosophy and squarely into the realm of science.
So from a tower of turtles all the way down to the Big Bang, our picture of the universe has gone through a profound transformation. We now know it had a beginning. Which, of course, leaves us with the next great question. Will it have an end?